see, I'm going to come around here, and for a reason which you will shortly see, I'm going to put on this coat to protect me. Thank you. The solar system has lots of rocks in it. Big rocks, small rocks, medium-sized rocks. Some of them are in the asteroid belt, where they range up to several hundred kilometers across, and they are sort of worldlets. Now, today, most of these small and large rocks are on regular orbits, which don't intersect. Collisions are few. But at the early history of the solar system, when material condensed out of a cloud of interstellar gas and dust to form the sun and the planets, at that time, there must have been many more such rocks, and they didn't know they were supposed to be on regular orbits. So they did intersect, and there were enormous numbers of collisions. Now the solar system has been cleaned up by all these collisions, and they happen rarely. But in the case of, say, the Moon or Mars, we see signs of those early catastrophes. And such craters happen today as well. For example, Meteor Crater, Arizona, is about 1 kilometer across and was produced by an impact of a big rock falling from the sky. Big rock falls from sky, makes hole in ground. Easy to understand. The reason there are so few craters on the Earth and so many on the Moon is not that the rocks in the sky know they're supposed to land on the Moon and not on the Earth. Oops, I'm going to the Earth, I better move over here to the Moon. No rock knows about that. It's that the holes in the ground are rubbed out on the Earth better, because we have running water, we have wind-blown dust. Those are erosive agents which can fill in and rub out craters. So just as many, more or less, craters are formed on the Moon as on the Earth, but the ones on the Moon survive because the Moon does not have many erosive agents, and the ones on the Earth disappear. So what often happens is something like that. Yes, I should warn the people in the front rows that this is going to be dangerous. And in fact, I shortly am going to call for volunteers, which will make it even more dangerous. So, the rock falls into the ground deeper than the thickness of this tray and makes a hole bigger than it itself was. And sometimes there is a lip. Sometimes there is a central mountain. Sometimes a set of rocks fall from the sky simultaneously and make some sort of pattern. Occasionally there's a crater overlapping another crater. And there are lots of things that can be done. Also, it's fun. Sometimes rocks miss planets. That's all right. We have to have some rocks left. Now, I think I need some volunteers who will enjoy making a mess of the Royal Institution. Good. May we have you and you, and I need one more volunteer, you in the green tie. And be careful that you don't step on any asteroids. And what I would like you to do is to take some handfuls of marbles, it doesn't matter what the object is, and one at a time, but pretty fast, start throwing them onto the Moon. Might be Mars, and I'll join you. Okay, so... Okay. Terrific. All right, we have one sticking up. Good. Okay, I think we have made a good first step, but let's try a few more. But don't throw. Let's just drop them in. Okay, we don't want to throw them hard because it'll destroy. That's right. Excellent. Good. Lovely. I'm going to now poke a few that are still sticking up down because there are no marbles to be seen on the Moon. And I'm not sure exactly what I will now do with this piece of Moon. Thank you very much. And I'd like to thank you for your help, because this is an important business of making craters on planets, and very few have a chance to do it. So maybe you can surrender your robes. Thanks. And I thank you for, oh, we have some asteroids left. Thanks very much. Now, let's take a close look. Mr. Coates can hold up a mirror at the results. And I think we got a lot of holes. Now, this is very close to what's called saturation cratering, where there are so many craters that one overlaps another, and you have hardly anything but craters and their debris. Now, that is the case in certain parts of the moon, but not in other parts of the moon. And I think it would be nice for us to spend a moment looking at the moon and seeing whether it bears some resemblance to what we've just seen. So now here is a photograph, in fact it's one we've seen before, of the moon. And the two major parts of the moon are the high, bright, heavily cratered areas, and the low, dark, lightly cratered areas. The latter are called maria, which is Latin for seas or oceans, because Galileo thought that these were in fact oceans. They are not. They are perfectly dry, bone dry. You can see a number of craters. Here, for example, is a dark crater. Here is one with a bright center. Here's another dark one. And as we look closer, we find tens of thousands of craters larger than a kilometer or so across. And a typical such crater is this one. We see the central mountain peak in the middle, which we did not find in any of our craters that we made in the Royal Institution a minute ago. But we understand the reason for that. That's produced by a rebound phenomenon, which could not have happened in this mud. We see the slumps at the crater walls, a kind of terracing. Sometimes there is debris which is thrown out by the impact. It is very similar to what we find in the laboratory. Now, the big basins on the moon, some of them are very large, many hundreds of kilometers across, are also produced by impacts, by bigger rocks falling. And I would like to show now a sequence of pictures showing how features on the moon probably formed. In the early history of the moon, in its final stages of formation, lots of rocks and debris were falling in, and there must have been an enormous number of craters to be seen. And here is an artist's view of how the moon must have looked in the final stages of its formation. But there were still some rocks to be acquired by the moon, and here is one in the process of hitting the moon, liquefying some of the surface layers, producing an enormous explosion, which then led to a multi-ringed crater, a sort of tidal wave, successive waves from the impact spreading out and then being frozen in the as the lava, the hot rock, freezes. Then, either through the energy of the impact or through internal heating of the moon, molten rock welled up and flooded these lowland basins produced by impact. And here we can see the dark frozen lava, and also the little hint of red in the picture is due to another impact happening on top of this. Then you can see in this picture that the dark low regions have very few craters on them. As time passes, no new major events occur, but new minor events occur, and these maria accumulate a sprinkling of additional craters over the following 4 billion years. Now that's a typical view of how major basins and craters form on the moon and on Mars. And so we expected there to be lots of impact craters on Mars. We had seen them from previous missions. And so when Mariner 9 was sent to Mars, we